Power system analysis series lecture 4. In this video we will be looking at per unit impedances of transformer. So we will be deriving some basic formulas for converting actual values to base values. That will be for voltage and for impedances. So first of all, in transformer ratio, we know that the primary side voltage by secondary side voltage is equal to the turn ratio, which is n1 by n2. And similarly for the current, the primary side current by secondary side current is equal to the n2 by n1 ratio, which is reciprocal of the voltage. So we want v1, so v1 will be equal to n1 by n2, and n2 will be v2 will be multiplied here. Similarly for I1, that will be the primary side is equal to N2 by N1 and I2. Now if I take it the base value of this voltage, so it will be V1B is equal to N1 by N2, the ratio will remain same, and this will be the secondary base value V2B. Same for the current, V1B is equal to N2 by N1, and this will be I2B. So now these equation will be using to find the impedances formulas. Now to get the impedance, we know that Z is equal to V by I. So using this same simple basic concept, Z1B will be equal to V1B for finding for the primary side impedance, and it will be I1B. Now these equations will be put in this Z1B V1 by I1 formula. So it will be equal to for I1 we will put this value n1 by n2. So it is n1 by n2, and it is multiplied with v2b by I1. So I1 is n2 by n1, n2 by n1 multiply I2b. Okay, let's write n2 by n1 is equal to a. So n1 by n2 will be equal to 1 by a. So continuing this equation, this will be 1 by a multiply b2b by I2b, and divided by this will be equal to a. We can write it as a1. We can write it as 1 by a square, and this multiply by v2b by I2b. So v2b and I2b will be written as z2b, and this is equal to z1b. So the primary side of impedance is equal to the secondary side of impedance base values multiply with the 1 by turn ratio square. So in this way we can find the base values of the transformer impedance of the primary side, and as well as from this equation we can find the secondary side base values. Okay, now let's look at the per unit quantities in three-phase system as well. We know that in the star connection of transformer, which is star connection of transformer, we know that the line voltage is equal to under 3 times of phase voltage, and in delta connection the line voltage is equal to phase voltage. So let's look in per unit system what are the equations for these two, line voltage and phase voltage in star and delta. So taking number one star connection, VL is equal to under root 3 times V phase. So we know that the per unit value is equal to actual by base. So VL is now here as actual, and we will write as VLB for base value. It will be VL per unit. Okay. So VL by VLB, which is base actual divided by base, is equal to under root 3 V phase divided by actual. and this is the actual value in nominator, and we write it as base value. So under root 3 under root 3 cancel. So here I can write VL per unit, and here I can write V phase per unit. The actual value, this is base value. So in per unit, the line voltage and phase voltage even in star connection will be always equal. Let's look at delta connection. Delta connection, V line is equal to V phase. Okay, so it will be always be also, so it will also be equal V phase base. Okay, so I can write it as V per unit is equal to V phase B, no sorry, per unit. So in star connection and in delta connection, if you convert both the values into per unit, then the line and the phase voltages will always be same.